I've spent the entire morning at the Mahindra's Chakan manufacturing facility outside Pune, where we've seen what goes into making Mahindra's new.
When Mahindra opened the doors to its new EV factory, no one was prepared for what lay inside. This wasn't just a production line, it was something else entirely. A place where machines think, systems react in milliseconds, and the silence feels engineered. What looked like an auto plant turned out to be a technological beast, rewriting every rule of manufacturing. India didn't upgrade, it leapfrogged. What exactly is going on inside this factory? And why are global rivals getting nervous?
So we're at the Mahindra factory, and this is a plant tour of how these EVs are put together and how they come together in Mahindra's state-of-the-art facility.
Join us as we look into what they found inside India's new Mahindra factory. The marvel inside India's new Mahindra factory. When the doors opened at Mahindra's new EV factory, the auto world wasn't expecting what lay beyond. It was a technological awakening. Located in India, the plant stretches nearly 3 square kilometers, more like a self-contained city than an assembly line. Roads run inside it. Buses move people between departments. Overhead, machines glide silently above the ground. Inside, the air is tightly controlled to protect sensitive components, and everything from lighting to logistics operates on sensors, software, and precise algorithms. The moment visitors step into the complex, it's clear that this isn't about producing electric cars the traditional way. It's about rewriting how manufacturing itself should work. Mahindra didn't just build a facility, they built a vision, a fully integrated AI-powered industrial ecosystem that might just put India at the forefront of the global EV race. How was the factory built, and what makes it stand out? Stay tuned, the most interesting part still lies ahead. In one section of the factory, raw metal coils are transformed into vehicle bodies without a single human hand ever touching them. The process is entirely autonomous. Robotic arms swing with the accuracy of industrial ballet dancers. Sparks fly, but nothing is out of sync. Every movement has been digitally rehearsed in advance. The robots follow choreography refined in simulation models before the foundation was even laid. Above them, lightweight guided vehicles move quietly across the plant floor, towing components heavier than most sedans. Even the floors shine not from cleaning crews, but from robots that sweep them every hour without fail. Color-coded lights on the walls signal the status of operations: green for normal, amber for inspection, and red if any issue arises. The system doesn't wait for human response. It acts instantly, rerouting support and adjusting in real time. In this factory, every second counts, and every inch is optimized. But it's not just automation that makes the factory stand out, it's flexibility. Where traditional plants may take months or even a year to reconfigure for a new model, Mahindra's setup needs only weeks. The production line isn't fixed, it adapts. When it's time to switch from one EV type to another, say from a standard 2-motor SUV to a high-performance all-wheel drive model, robots retrieve new toolkits and reset the entire system in under 4 minutes. Human workers don't handle tools, they manage data. Each shift is operated by fewer than 30 people, most of whom monitor the software and systems from tablets and digital consoles. Wearable devices project real-time diagnostics into their field of view. Engineers use this to step in if anything drifts from the norm. Everything, from torque readings to weld temperatures, is tracked live and stored securely through blockchain, enabling traceability that lasts for the car's entire life. Step into the press hall, and it feels more like a scene from a sci-fi film than a factory floor. High-strength steel sheets slide into gigantic presses, which strike with such speed and accuracy that it almost feels like watching a performance. Each press movement is adjusted by camera systems, making up to 40 corrections per second. The body parts that emerge float upward to the welding area, where over 500 robots work in perfect unison. Dual-arm setups bring pieces together, lock them magnetically, and weld them in seconds with lasers that are monitored in real time. If a weld fails to meet its strength criteria, the piece is immediately rerouted. There's no downtime. Above this section, a massive curved digital screen tracks every tool, every robot, and every parameter across the hull. The entire ecosystem is self-aware, diagnosing problems before they affect the line and executing corrections faster than any human team could manage. Even the material logistics run on intelligence. Robotic carriers, small but powerful, move supplies and parts like a coordinated swarm. Overhead, cranes lift entire car bodies and glide across tracks without collisions. What seems like chaos at first is actually a deeply controlled flow. When the assembly needs to switch models mid-shift, a brief flash of lights signals the change. Robots grab different kits, reconfigure their tasks, and continue as though nothing happened. No halt, no reset, just seamless transition. Behind this speed is Mahindra's private 5G network, allowing over 1,000 robots to communicate in milliseconds. Each action is logged, analyzed, and optimized. If a part starts heating more than expected or vibrates abnormally, it triggers a signal to the technician's wearable, prompting intervention within seconds. There's no waiting for things to break down. Maintenance is predictive, precise, and timed to fit between tasks, sometimes in windows as short as 7 seconds. Silence may be the most surprising element of all. Unlike conventional factories, there's no pounding of pistons or screeching of metal presses. Conversations carry across the rooms because the machines hum rather than roar. That silence is by design. Engineers say it helps them detect irregularities quickly. A hiss or a mechanical click becomes instantly noticeable. The factory doesn't just make work easier, it makes it smarter. This attention to detail extends to the people behind the systems. Mahindra has committed to increasing gender diversity on its production floor, targeting 25% female representation, a rare benchmark in India's industrial sector. The belief is that diverse minds solve problems faster, and the results are showing. From the robotic painters that decorated the walls with indigenous tribal art to the blockchain-enabled food supply chain in the cafeteria, this facility blends modern precision with local roots. Even its daily operations echo both technological prowess and cultural identity. The battery section of the plant is another level entirely. Step through an airlocked door, and you're met with a climate-controlled environment locked at 22 degrees Celsius and 40% humidity. These aren't just arbitrary settings. They're essential to protect the high-performance blade cells supplied by BYD. Each cell is long and slender, housed in sealed cassettes to prevent contamination. Here, the company uses a cell-to-pack design, skipping traditional battery modules altogether. This allows for higher energy density, up to 29% more than older setups. Machines insert each cell into skeletal housings with no human contact. Cameras check for flaws invisible to the human eye. If any imperfection is detected, the cell is removed, recycled, and replaced. Then, high-speed laser welders bond terminals into place, while infrared cameras track heat levels, ensuring strong, safe connections. Thermal gel is injected afterward to help control temperature during fast charging or high acceleration, making sure the packs perform under pressure. This part of the factory handles testing with the same unforgiving standards. Battery packs are shaken to mimic rough Indian road conditions, submerged in water for leak testing, and pushed into thermal runaway trials. Each pack is monitored by sensors that detect overheating and automatically isolate problem cells. Once a unit passes every test, it's cleared to join the chassis in final assembly. Yet despite the scale of operations, sustainability remains deeply embedded in the system. Laser welders send their excess heat to chillers that cool the dry room air. Spent solvents are processed to recover nearly all of the usable chemicals, and leftover waste is sent to be used as fuel in cement production. The entire setup is emission-free, no respirators required. Compared to older plants, This line uses 25% fewer consumables per kilowatt hour, outperforming even leading EV factories in China and Europe. Beyond all this, how does this factory work digitally? Let's get into it. The digital brain of Mahindra's EV factory. High above the quiet factory floor, nestled in a glass-walled structure that resembles a mission control center, sits Mahindra's command suite, the digital core of the entire operation. Here, engineers sit in theater-style seats, but their eyes never leave the massive ultra-wide displays in front of them. These screens stream real-time data from over 12,000 sensors spread across the factory, each feeding into a synchronized virtual model of every robot, panel, press, and battery pack. This system allows supervisors to track everything happening on the floor, from a weld seam's current flow to the temperature of a gearbox, without ever stepping out of the room. It's a digital twin that updates instantly, reflecting the factory's live condition with extraordinary precision. By tapping a single icon, an engineer can drill down to watch a specific torch's heat signature from last night, overlaid with CCTV footage for analysis. Speed defines how this brain operates. Mahindra uses edge computing built with NVIDIA GPUs to process visual and vibration data locally, without relying on distant cloud centers. The advantage is massive. Any irregularities, like a noisy bearing or a slow-loading arm, are flagged within milliseconds, fast enough to prevent the fault before it ruins a part. The latency in this system stays below 60 milliseconds, making decisions nearly instant. Only deeper analytics, like long-term trends or AI model retraining, are sent to the private cloud. This division between real-time and background computing helps the plant stay ahead of breakdowns. Instead of waiting for scheduled maintenance, the AI predicts wear patterns and slots in micro-maintenance tasks between jobs. For example, a tool might be recalibrated during the 7-second window between one car body exiting and the next arriving, eliminating traditional downtime completely. This real-time awareness doesn't just apply to machines, it also covers energy and resource use. Inside the same suite, dashboards display power usage across the plant, updated by the second. The software controls how and when to run energy-intensive processes. For instance, heavy equipment like paint ovens or compressors is programmed to run mostly during midday, when rooftop solar output is at its peak. By shifting energy loads intelligently, Mahindra reduces its dependence on external power grids and keeps costs low. Water consumption and recovery are tracked just as closely. Sensors monitor how much rainwater is harvested, how much is used in cooling systems, and how much is recycled. The result is a system that stays water positive, even during short monsoon seasons. Algorithms even prepare equipment ahead of the next shift by forecasting solar generation, ensuring nothing delays production. Cybersecurity is another layer tightly built into this system. Mahindra's factory uses a zero-trust security model, meaning even basic tools like torque guns must authenticate to the internal network before they function. Analysts in a side bay of the command suite monitor all incoming and outgoing data packets, running continuous encryption checks. To stay ahead of threats, the team conducts red team simulations, mock cyber attacks designed to probe weaknesses in the system. These exercises help tighten digital defenses and protect the valuable intellectual property stored within. The designs, welding patterns, and battery assembly data flowing through this network aren't just vital to Mahindra. They're strategically important to India's position in the global electric vehicle industry. Workers themselves are part of this tightly integrated loop. Ergonomic sensors in gloves, exoskeletons, and workstations feed live data into dashboards that monitor posture, muscle strain, and fatigue. If a technician shows signs of stress or improper form, the system recommends a task rotation to prevent injury. Smart wearables like vests and visors track individual activity and alert supervisors to potential risks before they escalate. These tools align the factory's safety efforts with ISO 45001 standards, not just in principle, but in measurable, real-time execution. When fatigue spikes are detected in one section of the floor, shifts are adjusted automatically, breaks are staggered, and lights in rest areas follow circadian patterns to improve recovery for night shifts. Transparency is central to the factory's culture, but not in a punitive way. Data isn't used to catch errors, it's used to prevent them. Each afternoon at 3 p.m., teams gather for the Kaizen Pulse, a daily meeting centered around continuous improvement. Engineers review live dashboards showing anomalies, corrective actions, and performance gains. If a robotic arm fails to meet welding accuracy, the cause is investigated, and solutions are applied that very day, not weeks later. One small issue might prompt a software update pushed factory-wide by evening. This habit of acting on data instantly compresses learning cycles. The result is a culture where iteration happens fast, and employees feel empowered to raise concerns or suggest improvements, knowing they'll be acted on. This philosophy of real-time improvement isn't just internal. Mahindra's system also tracks supplier behavior. Digital scorecards are maintained for vendors, giving preference to those who invest in renewable energy or wastewater treatment. This isn't a one-way demand. By rewarding sustainability across the supply chain, Mahindra nudges the entire ecosystem toward higher standards. Even small signals, like AGVs regenerating energy while descending a slope, feed data into the central grid to optimize output. These energy pulses may be modest, but they're symbolic of a larger intent. Every system, big or small, is expected to give something back. From a distance, all this instrumentation might sound cold or mechanical, but the engineers inside speak of the command suite with a sense of pride. They understand that every red dot removed from the digital map makes the vehicles safer for people on real roads. In this way, Mahindra's factory isn't just assembling electric SUVs. It's building a nervous system, one where sensors act as nerves, robots as muscles, and this glass-walled suite as the brain. The level of integration is so complete that disturbing one layer threatens the others. But that's also where the strength lies. Each part watches the others. Every second of data improves the next. And that, more than any single innovation, may be the real reason this factory is blowing minds around the world. With the kind of advancement India has made in the EV industry, were they always at the forefront? What was their breaking point? Brace yourself. What you're about to hear will blow your mind. How India went from EV underdog to global contender. Long before India began reshaping the electric vehicle landscape, the country stood at a crossroads, stuck between growing oil dependence, worsening urban pollution, and an auto industry largely trailing behind global innovation. For decades, electric mobility was an afterthought. India's early EVs were basic, often dismissed as golf carts with doors. Global giants dominated headlines while local firms stuck with conventional combustion engines. Yet something changed. A shift took root. And at the center of that shift was a group whose origins trace back to post-independence India, Mahindra and Mahindra, a company that would eventually become one of the most recognized names in India's electric transformation. Who founded Mahindra and when? You're at the edge of your seat, and it's about to get even better. The Mahindra Group was founded in 1945 by J.C. Mahindra, K.C. Mahindra, and Malik Ghulam Muhammad, originally as a steel trading company under the name Mahindra and Muhammad. After the partition of India, Ghulam Muhammad moved to Pakistan, and the company became Mahindra and Mahindra. It eventually diversified into automotive manufacturing by assembling Willys Jeeps in the 1950s. Over the decades, Mahindra built a reputation for producing rugged utility vehicles designed for Indian roads and rural terrains. But it wasn't until the 2000s that the company began to take electric mobility seriously. Mahindra Electric, formerly known as the Riva Electric Car Company, was acquired in 2010. That move gave Mahindra a head start, one of the few Indian automakers to invest in EV technology more than a decade before the mainstream push began. India's broader EV push didn't gain traction until 2015, when the government launched the FAME initiative. It was a policy meant to incentivize EV adoption, but in its early years, the impact was limited. The infrastructure wasn't ready. Battery imports were expensive. Domestic manufacturing capacity lagged far behind China or Europe. But a series of global and local shocks, rising oil prices, trade disruptions, and the climate crisis forced India to act with urgency. The breakthrough came after 2019, when the second phase of the FAME scheme introduced tighter targets and focused investment in both vehicles and core components like batteries, semiconductors, and charging stations. Suddenly, India wasn't just pushing adoption, it was racing to build an entire EV ecosystem from scratch. Mahindra responded with a bold vision. Instead of competing on legacy models, the company pivoted to create electric-first platforms. Its electric division invested heavily in R&D and began developing scalable architecture for multiple EV models. The goal wasn't just to make electric cars, it was to make them in India, for India, and eventually for the world. The company collaborated with battery suppliers, AI firms, and automation startups to craft what is now one of the most advanced EV manufacturing setups in the country. The launch of the new Mahindra EV factory in Chakan, near Pune, was more than just an expansion. It was a symbol of intent. This was where India would prove that its vehicles could match global standards and its systems could lead global change. What makes this transformation remarkable is how quickly India moved from observer to contender. Less than a decade ago, the country lacked even a basic charging network. Today, it is home to multiple EV assembly lines, battery pilot plants, and government-backed plans for over 6,000 charging stations across urban and highway corridors. Major Indian states like Tamil Nadu, Maharashtra, and Gujarat are offering production-linked incentives and tax breaks to encourage EV clusters. In parallel, companies like Mahindra are scaling domestic sourcing, reducing reliance on imports, and supporting local suppliers who embrace green practices. This isn't just industrial policy, it's a national push to claim a stake in the future of mobility. India's biggest strength in the EV race isn't just about how many vehicles it can produce, it's how adaptable those vehicles are. While many countries focus on expensive electric sedans or flashy SUVs, India is targeting practical, affordable mobility for everyday people. Companies like Mahindra are leading this push by creating EVs that are built tough, designed to handle heat, rough roads, and long distances without falling apart. These aren't just electric cars, they're smart machines powered by India's software talent and cloud innovation. That mix of hardware and tech makes Indian EVs appealing not just at home, but in developing regions like Africa, Southeast Asia, and Latin America. Mahindra is also betting big on the future of batteries. Their R&D center in Chennai is testing flexible formats that work with new chemistries like sodium-ion and solid-state, cutting ties with scarce materials like cobalt. This quick pivoting gives India a long-term edge, built not from one moment, but from years of pressure, planning, and persistence. Do you think factories like this will become the global standard? Or is Mahindra just an outlier? Could India lead the next industrial revolution through electric vehicles? Drop your thoughts in the comments. If you enjoyed this video, remember to like, share, and subscribe to our channel. Don't forget to check out the next video on your screen. You will enjoy it.